we had done saturated hydrocarbons and unsaturated hydrocarbons. And saturated hydrocarbons and unsaturated hydrocarbons. Right. So the saturated hydrocarbons we saw, they are the alkanes. Alkanes are the saturated hydrocarbons, and alkenes and alkynes, they are the unsaturated hydrocarbons. Either you have alkenes and alkynes, both are unsaturated, as they can perform addition reactions. Some of the substances can be added in them without any element being removed out of, or without any atom being removed out of it. Also, we saw over there addition
Sir,
reaction.
I had
Okay, Dhanunjay.
yes, sir.
So we see addition reaction of addition reaction. So first of all, which out of them will go addition reaction? Alkanes, alkenes, or alkynes? So it is only the alkenes and alkynes which go for the addition reaction. It's only alkenes and alkynes which go for the addition reaction, as there are, in the case of alkenes and alkynes, there is place for some element to be added up. So let's take up an example of this C2H4. C2H4. So the structure of C2H4 will be like this. So am I correct about the structure of C2H4?
Yes, sir.
Okay. And if I want to add hydrogen, so I want to add hydrogen to it. So it will be added in presence of nickel and palladium as catalyst. These will be the catalyst, nickel and palladium. Then hydrogen will be added. But to add hydrogen, there's a space has to be created. And to create that space, there will be a cleavage. That means this one of the double bonds will break. Okay, there are two double bonds, so one of them will break. So creating one free electrons. So it will be something like this, that you will have carbon, single bond carbon, you have hydrogen, like this, hydrogen and hydrogen, and some free electrons. One free electron will be generated with each carbon. The electrons which were participating in the formation of the double bond, they will be generated as free electrons. Now these are the bonding sites. At these bonding sites, other hydrogen atoms will bind together. So this will be your CH3, which will be C2H6. You will get your C2H6 as the output. Okay, so everyone understood this? This is a hydrogenation reaction. Hydrogenation means addition of hydrogen. Addition of hydrogen. Why it is important? I will be telling you why it's important. I will tell you importance for it. Now all the alkenes can go for this one, and alkynes can also go for the substitute addition reaction. In the similar way, you can take an alkyne like CH2, CH2. So CHCH, C2H2, which we took example yesterday as C2H2. The structure of C2H2 will be like this: C, H, and H. Now, if you add hydrogen to it, so again, in the presence of nickel and palladium, the bond will break. There will be breaking of the bond between them, and two bonds will break. only one bond will remain there. So it will be something like this, carbon with carbon and having hydrogen over here and creating two free electrons, one free electron here on each carbon, right? These are the bonding sites. So here other hydrogen atoms, they bind themselves.
So, but there are only two hydrogen atoms we are adding also.
No, there are not only two. The reaction we have not balanced. I think we are
Okay,
not,
okay, we can balance
okay.
it.
You can balance the reaction. I think Dhanunjay, this was the same doubt.
Yes, sir.
Okay. So the reaction was not balanced. I think you should have balanced the reaction. Just balance the reaction. If you add here 2H2, the reaction will be balanced. So now you will have your C2H6, formation of C2H6. Okay. So this is also a hydrogenation reaction. Now I will talk of why it is important. See, everyone, I think everyone must have heard about ghee and vegetable oil.
Yes, sir.
Out of these two, which one is costlier?
Ghee.
Ghee is costlier, vegetable oil is cheaper. Vegetable oil, it is obtained from the vegetables, ghee is obtained from milk. Okay. So is there both, but chemically, if you see, this is also a fat. Ghee is also a fat, right? And oils are also a fat. Vegetable oil, it's also a fat. So can you guess what is the difference between them? Any differences between them? Chemically, what is the difference between a ghee and a vegetable oil? It is that vegetable oil, it is unsaturated. This is an unsaturated hydrocarbon. Okay. And ghee is saturated hydrocarbon. Like, so we thought of that, is there any process by which can we make ghee from vegetable oil? So then we will be earning a lot of profit. See, market is every time searching for the products which can be duplicated. Okay. So like earlier there was silk which was made in China. So market started searching for artificial silk which gave rise to uh, rayon. Then we came to the polymers. So whatever is costly, we go on searching for something duplicate to it, which will be available at a cheaper cost and will have the same properties. Okay. So this is what we were trying. So is there any process by which we can convert vegetable oil to ghee? So then this would mean greater profit,
Hydrogen.
hydrogenation. Of course, we know that this is unsaturated, and if we add hydrogen to it, it will get saturated. Okay. So hydrogenation, it is also used in the conversion of vegetable oil to ghee, but that is actually not ghee, that we obtain as dalda. So have you heard about dalda? Yeah, it has appearance like ghee,
Sir, what's up?
dalda.
No, sir.
Okay, it has appearance like ghee, which is made from the vegetable oil. So vegetable oils, they are they are unsaturated. Vegetable oils are
Sir,
unsaturated.
daldas are made from vegetable oil, right, sir?
Yeah, from the vegetable oil, dalda will be made and this will be saturated. It is a saturated hydrocarbon. Okay, so dalda has its appearance like ghee. Just I will show how does dalda look like. You will, if initial case in the beginning you see, you will feel that yes, it is ghee. So let's see dalda. Okay, see. Okay, so these were the packets which were obtained. If you see open, now let me see if we have something open as dalda. So see, it just looks like ghee. Here, this one, it has this appearance like ghee. Okay. So the process of hydrogenation, it was designed basically to obtain a cheaper product in the market which has appearance like ghee. But this was not ghee. Okay. So I think everyone has understood about hydrogenation reaction.
Yes, sir.
Okay. Now there is another difference between unsaturated and saturated ones. That is combustion. Combustion. Okay. For the combustion of the unsaturated hydrocarbons, if you have any unsaturated hydrocarbons, so their combustion and a saturated hydrocarbon, right? So the unsaturated hydrocarbons, they burn with a smoky flame. They give a smoky flame. Okay. Whereas saturated hydrocarbons, they give a clear flame or clean flame. Okay. So understood? Unsaturated hydrocarbons and saturated hydrocarbons.
Yes, sir.
So anytime you should not get confused that which one were unsaturated and which one were saturated. Just a small mistake will make your answer just mixed up. Unsaturated means there is a space for something to be added up, and that space will be created from double bond and triple bond. Okay. Now all the alkenes and alkynes, they are unsaturated, and in the saturated ones you have all the alkanes. Now there is another question which comes out of all this, whatever we have studied, that is regarding the homologous series. So can anyone tell what are homologous series?
It is a family of a certain group of hydrocarbons like alkanes, alkenes, and alkynes.
And so family of hydrocarbons where each member, you will find, see, where each member differ by CH2 group. So every member differ by a CH2 group. CH2. Every successive member will differ by a CH2 group, which is a homologous series. For example, if you see CH4, so its next member will be C2H6. You just need to add CH2 to it. Its next member will be C3H8. It will also obtained by adding CH2. Next will be what will be the next member, Monish?
So C4H10.
C4H10. Okay. So in this way you can find out. Suppose for the alkenes you have C2H4. So what will be the next member?
C3H6.
C3H6. Dhananjay, what will be the next member then? Dhananjay, what will be the next member? Sir, what will be the next member of it?
Of what, sir?
Of this family. This is your family 1, which are called as alkanes. Of this family, can you name the next member?
The C4H8.
Hmm. C4H8. You need to add CH2 to it. Okay. By adding CH2, you will be able to obtain the next member of the family. So I hope everyone has understood about the homologous series.
Yes, sir.
Okay, definition is important. Keep an eye on definitions. Keep on learning the definitions also. Now, the next one. This was about the homologous series. Our next one is, this part is not in your book, but still you need to know this. Nomenclature. This will make your study a little bit easy. Okay. Nomenclature means how we name the organic compounds. Like we have seen the nomenclature of other compounds, like how we name NaCl. Okay. So NaCl or other compounds, other salts, how they are named. Their positive ion, cation is named first, and then anion. First cation is named, and then anion is named. For example, the name of this will be sodium chloride, okay, and not chlorine soda, sodium, not that way. It is the positive ion which is named first. Similarly, we follow some rules while naming the organic compounds. And can anyone tell me what are organic compounds?
Can I tell, sir?
Yes.
Organic compounds are the compounds which are from the living beings or living sources.
Okay, organic compounds, they are generated by the living beings or living sources. See what it actually means. You are very correct that organic compounds are the compounds which are generated or made by the living beings. You cannot make them in laboratory. You cannot make an apple in a laboratory. Okay, an apple contains those organic compounds, and if you think of creating an apple in a laboratory, that is not possible. So organic compounds can be made out of the organic compounds, okay, but they cannot be created out in the laboratory. If you suppose in the laboratory you want to create CH4, so you cannot. That has to be created by some living being. So there was some class of organic compound. There are some class of compounds which could not be generated in the laboratory, but those compounds, they could be made only by the living beings. So such compounds were called as organic compounds. So what do you
There
think
are few
about,
exceptions, right, sir?
yeah?
There are few exceptions, right, sir?
Okay. Can you give any exception?
Urea, sir.
So urea can be made in the laboratory also.
Yes, sir. It was prepared in the laboratory, sir.
Okay, so urea is prepared in the laboratory also. That is why we have those fertilizer industries. So urea, carbon dioxide, they are inorganic compounds. They are not organic. Even carbon dioxide is also inorganic compound. It's not an organic compound.
Sir,
Organ
but in our book, sir, like a separate column is given, sir. In that it's written like there was a vital force theory in which they said that organic compounds cannot be prepared in laboratory. But later, Friedrich Wöhler, he accidentally prepared urea, sir, while he was performing some other experiments, sir.
So he was he accidentally prepared urea at that time, and then it was said that okay, urea is inorganic.
Yes, sir.
Okay. So fine. This was something what by which we can strongly understand with organic and inorganic. So how we name them? First of all, to name any organic compound, you should search for number of carbon atoms. Okay, this is the very first point. Search for number of carbon atoms in parent chain. Okay. So you search for the number of carbon atoms in the parent chain. Then in the second point, you find out its family. That is it an alkane, alkene, or alkyne? So this is what you found in the second step. First, you find its parent chain. Then you find whether it's alkane, alkene, or alkyne. And then at the third step, you go for the substituents. What are the substituents added in this? Then we start naming. For example, if I take this compound as, okay, so how many carbon atoms are there?
4.
4 carbon atoms are there, and all of them, they are having single bond between carbon and carbon atom. So for the number 4, there is a word but. For number 4, the word is but, and it belongs to the class alkanes. So its name will be butane. Okay. Its keyword is but, and you will be suffixing it with the 3 letters A and E from the alkene. Then its name is butane. So you can have this meth, eth, prop, but, pent, hex, hept, oct, non, and dec. So meth is for 1, eth for 2, prop for 3, but for 4, pent for 5, hex for 6, hept for 7, 8 for oct, 9, and 10. Okay. So in this way, can you make the structure of propane? Can you make the structure of propane? How many carbon atoms will be there in propane?
3.
3.
3.
And they will be linked by single bond or double bond?
Single bond.
Single bond. Okay, there will all be single bonds, and the other bonds will be filled up with hydrogen. Okay, all the remaining bonds of carbon, they will be filled with hydrogen. Okay, Srilasya, can you show you? Have you drawn the structure of propane?
Yes, sir.
You just show it. Okay. 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 So propane, it is, you have carbon, carbon, carbon. 3 carbon atoms. So 3 carbon atoms joined together with single bond. The remaining bonds will be filled with hydrogen. Now, if I want to draw propene, so propene means there will be a double bond, just one double bond. Not everywhere. There will be just one double bond between any 2 carbon atoms. Like C, I can write here double bond C and another carbon. Now the remaining bonds will be filled with hydrogen. So this is how it is. Hydrogen, hydrogen. So this is the structure of propene. Okay. So let's draw butene. Let's draw butene. Draw butene. Dhruv, have you drawn?
No, sir, I'm drawing.
Okay. So everyone will show this, a diagram of butene once you have completed. Okay, Dhruv. Fine. Okay, Dhruv. Dhruv, just see, is there any other structure possible for butene? Is there any other structure which is possible for butene? Medha, Ansini, Vedika, have you done?
Sir, I don't know, sir, if mine will be visible, sir, because like there's a crack right in front of my camera, sir, on the mobile, sir.
Okay. Okay, so this one, okay, it's correct. Fine. Butene is correct. Anyone else? Vedika. Vedika, just hold on. For the carbon at where you have made the double bond, count the number of bonds. Vedika, count the number of bonds to the carbon. Second carbon from there. Okay. Anyone else? Monish? Monish?
Yes, sir, I'm just doing it.
Okay. Vedika, have you done? Um, okay, Monish. Just wait. For the second carbon, count the number of bonds. Count the number of bonds for the second carbon or for every carbon. Count it. Monish,
Okay,
count for every carbon.
yes.
Is it everywhere? Are you getting 4 or somewhere you are getting 5? Count it. Okay, Dhruv. Okay, Dhruv. You also. Okay, Dhruv. It's okay. See, while making the bonds, you must count down the number of carbon atoms. Okay, okay, Medha, you are not sure. So learn it here. Fine. Here in this class only I am teaching everyone. Just to how to draw the structure, we have started here only. In the last class, we did just a small, we did a small topic of electron dot structure. So see, if you draw butene, its structure is possible like this with two hydrogen over here. one hydrogen here, 2 and 3. So this is a structure of butene. Now, not only this, another structure is also possible. You can draw it something like this also. C, double bond carbon, and this. So this is another structure which is possible for the same butene. But their chemical properties will be different. You can see both are butene, but their chemical properties or physical will be slightly different from one another. Okay. So these two, they are the isomers. We call them as isomers. Okay. So isomers are the compounds which have same chemical formula but different structural formula. So what are isomers? Isomers, they are compounds with same molecular formula but different structural formula. Okay, you got about isomers. What are isomers then? Compounds with same molecule formula, just like butene we saw. Okay, they have their different structural formulas. Here, the double bond is on the first carbon, and here the double bond is on the second carbon. So now, can you draw the structure of butane? Just draw the structure of butane. Draw butane. Okay, who has drawn butane?
Sir, I have drawn it.
Okay, so I can see one. Dhanunjay, yours is correct. Okay, Monish, yours also correct. And Shreyasi. Okay, Shreyasi is also correct. Tanishka and okay. Who else is showing? Vedika. Vedika, just hold. Hold Vedika. Yeah, Vedika, it's correct. Then who is left? No, spotlight. Okay. So yeah, Srilase, yours is also correct. You can turn off. This one, Dhruv. Okay, Dhruv, it's correct. Dhruv, you have not made all the hydrogen. For the first carbon, just check the number of hydrogen for each carbon and number of bonds with each carbon. Some hydrogen atoms are lagging. There are less hydrogen atoms. Okay. Yeah, now it's correct. Okay, now it's correct. So everyone can make these. No problems over here in making these formulas. Okay. Now see, there is adding something extra. Suppose instead of hydrogen, you have a halogen group. Suppose we add the group halogen to it. So let's see now, halogens. So halogens, they are fluorine, chlorine, bromine, iodine, and astatine. They are the halogens. If these are added in the group, for example, if it is something like this, CH3Cl, CH3Cl, here you have 3 hydrogen atoms, but there is 1 chlorine atom. Okay. So how do we name this? Whatever halogen is present, it is prefixed. Its name is prefixed with the word halo. We attach the word halo before it. For example, here chlorine is added, so its name will be chloro. We will prefix chloro, and there is single carbon, so it will be meth, and all are single bonds, so it will be methane, chloromethane. In the similar way, we can make bromoethane. Can you draw bromoethane? Okay, draw about bromoethane.
Done, sir.
Done. Okay, Shashi, just wait. Wait.
So mine also completed.
Okay. Okay, Shashi, bromoethane. Okay, yours is correct, Shashi. Okay, who is saying Dhanunjay? I can't see your bromine. Where is bromine? It's first one. Okay, it is correct. Monish, okay, Monish, it is correct.
Yes, sir.
Okay, so I think most of you can make. All of you, I think I can make. Everyone knows now the nomenclature of halogen compounds. Okay, what will be the name given to this? C, Cl, H, and H. So what will be the name given to it? Can you think of any name?
CH2Cl2.
That is the formula CH2Cl2. What will be its name?
Dichloromethane.
Yeah, it will be dichloromethane. As there are 2 chlorine atoms, so we prefix di. So it is dichloromethane.
So if it's 3, 4, 5, can you like tell what will come in the starting, sir?
Then if it is 3, so it will be tri. Okay.
4.
If it is for 4, the system will change. Okay. If you have 4 chlorine atoms like this, for 3 it will be tri. Okay. This you understood. And if there are 4, so like carbon, it has all the chlorine. So is it an organic compound or an inorganic? Now this is an inorganic compound, CCl4.
Inorganic, sir.
Okay, this is CCl4, inorganic compound, and it is carbon tetrachloride. Okay, so it does not it will not follow the rules of nomenclature of organic compounds. So now along with it, we will continue with the nomenclature. Nomenclature has not ended. We will continue with it. But there are some things which will do some reactions. Like we will do the elimination reaction. elimination or substitution reaction. Elimination or substitution reaction. Okay. Elimination or substitution reaction, it is generally possible or generally done in the saturated hydrocarbons. All the saturated hydrocarbons, they go for elimination reaction as there is no free space. There are no free bonds. Okay. So they go for the substitution or elimination reaction. For example, CH4. Okay. If to the CH4 you add chlorine, so it will turn out to be CH3Cl. Its name is chloromethane. This is its IUPAC name, chloromethane, and you will also get here hydrogen. So that's why I told you that every time in the case of organic compounds, you should not go for balancing. You can write down the reaction. Otherwise, if you can, that's very good. You can balance these reactions.
So it will be HCl, no, sir, in the end.
Yeah, in the end, it will be HCl, sorry, not H2. It is HCl, right? So at the end, it gives you HCl, chloromethane. Now, there is there is a compound which is chloroform. What is the chemical formula of chloroform? Anyone knows the chemical formula of chloroform? It is used as an anesthetic. Anesthetic means it was used by doctors to make someone what we call as someone who is unconscious. During the operation, chloroform is used for making people unconscious. So the formula of chloroform is CH3Cl, that is chloromethane. Your chloromethane, it has the common name as chloroform. Okay. So,
CHCl3.
yeah.
CHCl3.
Okay.
Chloroform.
Is it CHCl3 or CH3Cl?
CH2Cl2.
Now, even after this, addition reaction can continue. You can have CH3Cl reacting with other chlorine to again give you CH2Cl2 plus HCl. Then addition reaction can further continue till at the end all the hydrogen are replaced. You can further have replacement of CH2Cl2. Another chlorine can be added up so that you obtain CH3Cl plus HCl. Further it can be added and at the end you will get your CCl4, which is your carbon tetrachloride. Okay. So a question may come from where? What are anesthetics?
So the last one will be CHCl3, no, sir.
Yeah.
The last reaction should in the product should be
Okay.
CHCl3.
Yeah, it should be CHCl3. It's CHCl3. So you have the formation of chloroform, which is used as an anesthetic. Okay. So these were the elimination reaction or substitution reaction. So today we have done two types of reactions. We have done addition reaction and we have done elimination reaction also. Addition reactions, they are performed by, or addition reactions, they are performed only in unsaturated hydrocarbons. And elimination reactions, they are performed in saturated hydrocarbons. is 742. Fine. So let's continue with the nomenclature. Today we have learned about the nomenclature of halogens. Now, methyl group as substituent. Can we have a methyl group as substituent? Methyl substituent means CH3. For example, if you try to name this, okay, what name can you give to this? Okay, we start with our initial steps. So at first step, our option was we choose the parent chain. Okay, so in the parent chain is the one which contains the largest number of the carbon atoms. Okay. So what is the largest number of carbon atoms? Largest chain of carbon atoms?
4.
Yes. 3. Okay. It is 3. The longest chain of carbon atoms, it is made of 3 carbons. You can see this is the longest chain of carbon atoms. So we can call this to be the parent chain, or we can also take this one also as the parent chain. See, this one also contains 3 atoms of carbon. Okay. Or you can choose this one also. You can choose this one also as the parent chain. All of them, they have their equal validity. Okay, this is the longest chain. Now, if you look up in the first case, we in the beginning we go with the first case, this one. We choose this one to be the parent chain, and in this parent chain, we start marking the carbon atoms from either side. We can either start marking from here, or we can start marking from here. Okay, it's just like this. Suppose you are given these balls. Okay, and let me name them as A, B, and C. So if I tell you which one is the first ball, so first ball can be either A or it can be D also. It depends from what side you start counting them. So in the similar way, now we will be numbering these carbon atoms from either side. We can either start from here or from here. So it will be 1, 2, and 3. Okay. You have a substituent group methyl at the second position. At the second carbon, you have attachment of a methyl group. CH3 is the methyl group. So its name will be 2-methyl. Okay. 2-methyl, and its parent name is propane. So 2-methyl propane. Okay. Got it? Understood? Okay, now in the
Yes.
last 2 minutes, if there is any doubt from whatever we have done, you can check from the beginning. I'm giving you 2 minutes, check from the beginning. Nomenclature, homologous series, substitution reaction, saturated, unsaturated hydrocarbons. Okay, Dhruv, any doubt anywhere?
No, sir. No answer.
Okay. So, okay, anyone who knows can answer. What are the different chemical differences between between saturated and unsaturated hydrocarbons? Differences between saturated and unsaturated hydrocarbons.
Saturated give a clear blue flame, and unsaturated give a sooty yellow flame.
Yeah, saturated ones, they give a sooty yellow flame. Okay. And there more amount of oxygen is required for their combustion. So hence they generally give a sooty flame. So vegetable oils, they are saturated or unsaturated? Unsaturated.
Unsaturated.
Unsaturated. And dalda ghee? Saturated. Okay. So dalda ghee, it has another name. I'm giving you another name of this dalda. This is also called as vanaspati ghee. Vanaspati means plants. So that means ghee of plants. That is vanaspati ghee.
Yes, sir.
So bye everyone. Good night.
Thank you, sir. Bye, sir.
Thank you so much.
Thank you, sir. Bye, sir.